In this video, we are going to solve numerical on initial and final values of Laplace transform. So we are supposed to find out initial and final value for the given x of s, which is s plus 2 upon s square plus 2s plus 1. So let us begin with the first part, initial value. So according to initial value theorem, we have the equation for initial value as x of 0 is equal to limit s tends to infinity s into x of s. So let us substitute the values in this equation. So limit s tends to infinity s into s plus 2 divided by s square plus 2s plus 1. Now here we have the limit tending to infinity. So whenever we have initial value theorem, limit tending to infinity, in that case try to take s common from numerator and denominator and cancel out the s terms. So here limit s tends to infinity. So from numerator let us take s common. So here s into s which is taken common, it becomes s square 1 plus 2 by s divided by, in denominator also we have taken s square common, so that s square can be cancelled out. So the remaining term is 1 plus 2 by s plus 1 by s square. Now in this case we can cancel out this s square. The remaining equation becomes limit s tends to infinity 1 plus 2 by s upon 1 plus 2 by s plus 1 upon s square. So simply apply the limits. So we get the equation as 1 plus 2 by infinity divided by 1 plus 2 by infinity plus 1 by infinity. Infinity square is again infinity. So our answer is 1. So the initial value for given example is 1. Remember here, whenever you are finding the initial value, in such cases check the given equation. So here the given equation was s plus 2 upon s square plus 2s plus 1. Then we have taken the expression for initial value theorem, limit s tends to infinity s into x of s. So x of s is s plus 2 upon s square plus 2s plus 2. So in numerator, if you look at this particular expression, here in numerator also we have s square term, in denominator also we have s square term. So we can cancel the number of s, so that we can apply the limits and 1 by infinity becomes 0, and accordingly we can get the answer. So initial value is 1. Similarly, now let us find the final value. So according to final value theorem, we have the equation as x of infinity is equal to limit s tends to 0 s into x of s. Never forget to write this s. Many times we forget to write this s, so it is s into x of s. So substitute the equation now. So limit s tends to 0 s into s plus 2 upon s square plus 2s plus 1. Now whenever it is final value, our limit is tending to 0. So we should not rearrange the equation where we get the term like some constant upon 0 while taking s common. So in this case, if we try to take s common from denominator, we get 1 by s, and 1 by, once we substitute the limit, 1 by 0 becomes undefined. So we should not simplify this expression where we get the terms like 1 upon s or in that way. So here we cannot simplify, we cannot cancel out the s term. So straight away apply the limit, and after applying the limit s tending to 0, we get the answer as 0. So our x of infinity in this case is 0. This is the final value for the given equation. So in this way we can solve the numericals for initial and final value. Only remember a trick in this case. Whenever it is initial value theorem, try to take the s common from numerator and denominator and cancel those terms and then apply the limits. Whenever it is final value theorem, s is tending to 0, so do not here also we need to cancel out the s from numerator and denominator, but we have to take care that we should not get the terms like 1 by s. If we do not get the term 1 by s, straight away apply the limits, we get the final value. So for this specific numerical, initial value is 1 and final value is 0.